In today's short video, we are going to deal with a very common misconception regarding a speed of a particle or speed of a body. In general, a speed is defined as distance covered by a body in 1 second or in unit time. So you define a speed v equal to distance over time, that is symbolically s by t, where s represents the distance and t time. As s and t are present in this equation, so common people think that speed v will depend on s and t, that is distance and time. But this is a common misconception. In fact, the speed v does not depend on s and t, but it depends on the distance as a function of t. It means how the distance varies with t, what is the functional form of distance, that determines speed, but not distance and time separately. Now let us explain this fact. If you say that the speed depends on distance s and time t, then it is obvious that if we are given distance s and time t, then we can easily find the speed of the particle. But you will see that it is not possible always. Let us consider for an example that a particle starts moving at time t equal to 0 from the origin on x-axis. So if you try to find the speed of the particle at 0 time, so as the particle starts moving at t equal to 0, so distance covered by the particle in 0 time is also 0. So here in this example, s is 0 and t is also 0. 0 distance is covered in 0 time. So what will be the speed at time 0? V of 0 means speed at time 0. This will be in fact 0 divided by 0, and you know from mathematics that it is indeterminate. It means from these informations we cannot find the speed of the particle at 0 time. Okay, so you can think distance was given, time was also given, but you are unable to find the value of speed. So you can say that speed does not depend on distance and time. Okay. Now let us take another example. Let us consider that a particle starts moving from this point A at time 0, and it moves from A to C fastly. I have written here fast, and then the speed of the particle decreases, it slows down, and then it moves from C to B, and at point B it reaches at a time t equal to 10 seconds, and the path length ACB is equal to 100 meter. It means this particle has covered a distance 100 meter in 10 seconds. So if you find the speed of the particle from that definition, that will be simply 100 meter divided by 10 seconds. Okay, and what will be this? This will be 10 meter per second. So this result shows that the particle moves from point A to B always with speed 10 meter per second. But you have assumed that during the motion between A and C, the speed was, let us say, v1, and between C and B it was v2, and in accordance with our assumption, v1 is greater than v2. Then this unique value of speed does not correspond to v1 and v2 both. So if we know that v is equal to s by t and it depends on distance and time, then it will be possible only when the particle will move with a constant speed. But in case of variable speed, this definition will be wrong. Okay. Actually, this value we will learn in further lecture, that this represents the average speed. when you say that the average speed of the particle between points A and B is what, that answer will be 10 meter per second. But you cannot say that speed at any moment is equal to 10 meter per second. So from these two examples, I think it is clear to you that the speed does not depend on S and T, because S and T are given, but we are unable to find the correct value of speed. Okay. Now then we must think what will be the exact definition, correct definition of speed. Actually, speed is defined as a first order derivative of the distance function with respect to time t. It means differential coefficient of distance with respect to time t that measures the speed at any time t. And you know from this mathematical definition that if v is equal to ds by dt, it means v depends on the fact that how s varies with t, because the value of this derivative will be different for the different functional form of distance. It means the relation between s and t will determine the value of speed. Okay. And to explain this fact, let us consider one of the example, that s is equal to at, where a is a constant. Okay. When you say s equal to at, it means this equation is just analogous to y equal to mx, which represents a straight line passing through the origin. So you can say that here distance function is varying linearly with time t. So distance is a linear function of time t. In this condition, if you will plot s in against of t, the graphical plot will be a straight line as I have shown in this figure. And if you try to find the speed of this particle at any time t, what will be that? That will be ds by dt, and from calculus you know this will be simply equal to a, which is constant. What does it mean? It means the speed at any time, it means speed at 0 time, this will be a. Speed at 1 second, this will be also a. Speed at 2 seconds, this will be also a. So you can see when the relation between s and t was given, we are able to find the speed even at 0 time. But in the previous example, you were unable to find the speed at 0 time because their functional relation between s and t was not given, but only distance and time was given. Okay. And you know that this ds by dt, in accordance with geometrical meaning of dy by dx, this is equal to slope of this curve, this is tan theta, and as the slope of a straight line is constant, so this functional relation implies that the speed of the particle is constant and it will be same at any time. But now let us consider a non-linear relation between s and t. We have considered actually a very simple relation. This relation is s equal to at square. Here you can see that at t equal to 0, s is 0, so the point will be at the origin, and the graphical plot will be a parabola, because this equation is in the form of equation of a rectangular parabola. This is y equal to ax square. In fact, in this condition, if we will try to find the speed at any time t, what will be that? That will be ds by dt, and you know ds by dt will be what? This will be 2at. And so you can see that this equation refers that speed is a function of time t. So the speed at different time will be different. If you will try to find the speed at 0 time, this will be simply 2a into 0, and that will be 0. And if we will try to find it at 1 second, this will be 2a. Okay. If you will find it at 2 seconds, this will be 4a. So you can see that at different time the speed is different, and we can find it because we are given the functional relation between s and t. So finally, we conclude from these examples that speed does not depend on distance and time, but it depends on the functional relation between distance and time. or in other words, you can say that speed depends on the distance as a function of time. Okay, thank you very much.